In this video, we are going to learn about energy signal and power signal and with theory along with problems. First, let us go with the theory. So, energy signal general example is camera flash, clap sound, which means exits for a short time, dies out after some time. So, it has limited total energy. So, therefore, it has limited total energy. When you go for the general example like camera flash and clap sound, so this will exit for short duration of time, right? So dies after some time, so that's why it has the limited total energy. Now therefore it has total energy is finite and average power is 0. So now it has total energy is finite and average power is 0. Okay, remember these things. Now when we look into the power signal, the general examples are electrical AC signal. So continuously rotating fan, which means they continue forever. So electric AC signal or continuously rotating fan will continue forever, right? So means it has finite average power. So now therefore it has average power as finite and total energy is infinite. So this electrical AC signal or rotating fan will have infinite energy and average power is finite. So for energy signal it is a short duration, right? So that's why the average power is 0 and total energy is finite. Okay, remember these things. Now in technical terms, best example of power signal is sine wave. For energy signal is you can consider as pulse signal. Okay? Now let us move into the problems. Okay, we're done with the theory. Now let us go for the formula of energy signal and power signal. You can take down these formulas. Okay, this is for continuous time signal, this is for discrete time signal. Same way for the power signal, and for the power signal this is for continuous and discrete. Okay, note down these formulas. Now let us look into the problems. First problem is given x of t is t u of t, where u of t is a unit step function. Unit step function means the function will look like this. Unit step function. So this is the graph for the unit step function. Okay, 1 0. Okay, when t greater than or equals to 0, sorry, when t greater than or equals to 0, the u of t will be the 1 here, otherwise 0. Okay, otherwise 0. Now same thing, let us write in terms of function. Here unit step function is when t greater than or equals to 0, it is a 1, and t less than equals to 0, it is a 0. Okay, now this is for unit step function. We need x of t. X of t is t u of t. Now x of t is multiply with the t. T means just here 1 into t. When t greater than or equals to 0, 0 into anything will be the 0 only, right? So that's why when t less than or equal less than 0, it will be the 0. For the energy, let us use the formula. So this is the continuous time signal, right? Let us apply the continuous time signal energy formula. So minus infinity to infinity x of t whole square dt. Now here minus infinity to 0 is one term, 0 to infinity is another term. 0 into something you can write or won't write, it won't affect. The thing vary at when t greater than equals to 0, right? So like 0 to infinity, it is a t square dt. When you do so, you will get energy as infinite. Okay, energy as infinite means it is not a energy signal. Okay, we are left over with either power or not. We need to check. Let us check for the power signal. Now when you apply the power P, limits t tends to infinity 1 by 2t 0 to t. This t means t over 1 period. Okay, t square dt. When you apply, so you will get, when you do this thing, you will get P as equals to the infinite. So average power is also infinite, means it is neither the energy or nor power signal. Okay, we can conclude that when energy is infinite, power is infinite, it is neither the energy or nor power signal. Okay, I hope you got the idea on this. Now let us move for the next problem. Given x of n is 1. So means it is the n, means you can directly conclude that it is a discrete time signal, right? So for the discrete time signal, use this, like summation n is infinite to infinite 1. So means energy equals to infinite. Okay, let us apply the power. So energy is infinite, means it is not a energy signal. Okay, now let us go with the power. Let us check. So limit n tends to infinite 1 by 2n plus 1 summation n equals to minus n to n x of n square, means something, when you do so all this, you will get infinite by infinite. Okay, like this case here we done, right? When we done, so what we got, this thing we got as infinite. So here bottom, like at the denominator also, you will get something infinite. Infinite by infinite, something gives the results as 1. So that's why the power signal is finite. Now when energy is infinite and average power is finite, means that signal is known as power signal. Okay, till now we are discussing with the formula. Let us go with the trick. For energy signal, what we discussed, like a sudden spike will result a energy signal, means the graph somewhere is like a sudden spike or a duration and it will rest down. So the signals are energy signal. So this won't continue again. Okay, now power signal means for all time it should be repeat like this. Okay, or the graph will be like this, or the graph will be some kind like this. This is all known as the power signal. Now by this we can state that x of n is 1. So at any, instead of time, like at any n, x of n will be the 1. Okay, so means this will continue forever, right? So continuing forever, this graph will matches under the power signal. Directly you can say this is the power signal. Now previous example, let us say once with the same trick. X of t is u of t, right? Like first let us plot the u of t graph t. So this is the u of t. Okay, when t x of t means this will goes like this, right? So means this will neither comes under the energy signal or nor power signal, right? Either you need to get a sudden spike or you need to get a continuous graph. So this will not match under any of these graphs. So that's why it is neither the energy nor power signal. Okay, now let us go with the this graph x of x power minus 2 u of t graph, right? U of t is like this. So a part of this like exponential graphs will either like this or like this. Okay, so a sudden spike to down or a downs to sudden spike. Okay, When you multiply with this, you will get the same graphs. Okay, means this will match under the energy signal. Okay, this will match under the energy. Now let us prove with the formula. So e power minus 2t into u of t, which something sounds with this, it is known as the continuous time signal. Okay, let us apply the same energy formula with respect to the continuous time, like 0 to infinite means u of t will present after the 0, right? So that's why directly you can take 0 to infinite e power minus 2t square dt. When you do so, energy signal you will get as 1 by 4. Now power, so this thing we done here, right? Directly apply 1 by 4 here. 1 into 2 infinite, like take the 2, like now apply the limit of t, which is like infinite, to this t, which is like 2 into infinite, like we will get 1 by infinite. 1 by infinite tends to the 0, which have finite power, sorry, finite energy, and average power 0. So which is the criteria for the energy signal. So by the graph solely we can say that it is the energy signal. This is how, by the general trick and with the formulas, how we can find the energy and power signal. I hope you got the idea on this. If you learned anything in this video, please do a like and support by subscribing. Thank you for watching this.